Good. So I'm happy you are here, and I'm happy to start the second day of the conference. I hope you had fun on our first day. And it's kind of weird to have this talk in the morning because we are super jet lagged. So actually, I should ask Dylan for next year to put the European in the afternoon and the American in the morning, such that you don't have problem with jet lag. So the talk of today is titled Cybercrime in the Deep Web. This is a research I started with Vincenzo pretty much 3 years ago. So I was in Chile, in South America, for a conference called 8.8, and I met a friend of mine from Argentina. He's called Claudio, and they want to basically acknowledge him because he was the guy that showed me the deep web 3 years ago. I didn't know what it was about. He showed me, how you could serve the deep web using Tor, and it was kind of interesting of what you could find there. So basically, the idea of the project here was to, let's start to collect as much data as we can of the deep web, try to do an analysis kind of an automated way, and see, what we can find in the system. So briefly, we both work nowadays for Trend Micro as senior researchers, and I'm going to skip this just for reference because we have a bunch of slides, so I don't want to go over time. So the roadmap of today is, as I said, introduction on the tool, how it works, kind of internal, and explain what we can do with the tool, which kind of analysis we can do, and then we present some of the things we saw in the deep web, going from illegal trading of passport, any kind of goods, to malware, for example, and then we conclude with some lesson learned. So I will give now the talk to Vincenzo, and then we'll come back when we go to the malware section.
Okay, thanks, Marco. So let me start and conquer you all by being extremely pedantic here. These are 3 definitions that you will find around reading about the deep web and so on, and it's important to have them clear. So the deep web as a buzzword, it came out about 10, 15 years ago with the first research when researchers try to estimate what was the actual size of content that would not be caught by search engines, so all unindexed content on the internet. Which means, in the stricter sense, also everything that is, for example, dynamic web pages, sites, behind logins. Your home banking sites, for example, might very well, fall into these definitions. Any sites with a proper robot.txt configured. I mean, this is the broad definition of deep web. Then we got darknets, which are what you might imagine. They are like Tor, I2P, and so on. Actual software that creates an overlay network, private overlay network, usually aimed to let you surf anonymously, securely, in an untraceable way, and so on. And then you got the dark web, which is web content hosted on darknet. So those things like hidden services and hidden sites that you find on Tor and I2P. And we need to make this distinction because more often than not, you find quotes like this. Now, I don't know if anybody have watched already the DeepWeb documentary. It's a documentary came out this year about the whole Silk Road trial, the whole, events that happen on the back, and so on. And if you watch the trailer, you can actually go on the internet, maybe not now, like later on, and it opens with this sentence, very dark voice that says, the deep web is vast, thousands of times larger than the surface web. Which is formally correct if you take the original definition, it's vast, of course, you got like your home banking sites and everything. But if you look at it's a kind of a double truth. Like, it's true that it's vast, and it's true that you got some malicious content on top. But when you take the 2 definitions together and you want to focus on what's interesting there, it's not really that big as they want you to, or as they claim it is. So this is the first thing that is important to consider. Like that image of an iceberg with the surface tip and the massive ice submerged content on top doesn't really apply when you look at cybercriminal sites and cybercrime material, for example. So in our research, we wanted to focus on this subset of the deep web particularly. So we wanted to focus on what is dark web. So again, Tor, system like Tor, I2P, FreeNET was another one. We also tried to look at things like custom DNS, so services like Namecoin and Emmercoins. And we wanted to keep an eye also on what are still existing rogue top-level domains. Because all these systems might offer, to cyber criminals, basically infrastructure that would be resilient to, law enforcement actions like sinkholing or takedowns, or at least make it difficult, not probably immune, but at least make it very difficult. They could offer, places to securely share goods, into marketplaces and so on, and in general, provide a safe haven for information exchange. So this is our subset. Now, raise your hands if you know more or less what Tor, I2P, and FreeNET are. Okay, excellent. So I'll go very quick on the next few slides. So FreeNET is the oldest one of all. Is actually the main difference that's important here. The main difference between Tor and I2P is just that it doesn't really provide services like servers, encrypted connection to servers. It provides data lookup. So there are static resources like web pages and pictures or files in general identified by a key. You issue a request in your, it's a peer-to-peer neighborhood. You issue a request for a key. The request gets gossiped until it's found somewhere. Get it back. Got your thing. So you can't really have full-fledged servers, but you can still host static sites on that. Following, the spiritual son of I2P was FreeNET was actually I2P. Again, full dark web allows you to access hidden services. Usually they're identified by a .I2P top-level domain. It has a routing system called garlic routing, which relies on a set of encrypted tunnels with multiple levels of encryption and so on and so forth. Then you got Tor. Again, big thing here. As you know, initially it was just for anonymous browsing of Surface websites. So go on your sites and being anonymous there. The later time, they actually managed to implement hidden services on top. So host services anonymously for both user and server there. Onion routing, again, multi-hop routing with multiple encryption keys so that every step of the routing, you never know exactly where did the request came from and where is it going. You just know the previous and next step at every hop. A word on Namecoins and Emercoins. These are pretty much an alternative system of DNS, where the way to register your domain works not through a regulating institution, but through the blockchain server. So imagine like a Bitcoin blockchain, except that instead of storing payment transactions, you store domain name registrations. So it's distributed, decentralized, no regulating institution, makes it very nice system to register malicious domains, for example. And then we sort of wanted to keep an eye also on the old rogue TLDs. These were fairly popular in the 90s, where you had competing system for DNS registrations with their top-level domains. There are still some out there that offer this custom DNS, mostly for political reason or, well, in case of Sicilian root, is like just pure batshit craziness, I'd say. And it could still offer malicious actors ways to actually register domains outside of the ECAN jurisdiction. So with this in mind, we decided to pretty much develop a tool to support our team of analysts and investigators that they could use to do research on the content of the deep web. So collect all the data we could find pretty much related to deep web URLs, so Tor, I2P, custom domains, and so on. We wanted to provide them with a tool that they could use during their investigations, a tool for us to do some research and find interesting content, basically. So this is a broad overview of the system. We pretty much have a block that takes care, again, of URL acquisition. So we try to pretty much harvest URLs from everywhere we can. We index those URLs in terms of the events when we find one, the URL themselves. So we index them as complex objects so that we could pull statistics out of them. And we index also scouting information. So the third step is actually go and scout to see what's at a certain URL. Is there a website? Is there some open ports? If there's a website, what are the HTTP headers? We'll see they might be useful actually on their own. What's the page content? We pull screenshots and all sorts of stuff. We enrich that data, for example, pool some ratings for the links, cluster the text in order to get some meaningful workload, and so on. And we can examine the data using basically two interfaces. One is an in-house developed website that we use to pretty much look at the data, especially the scouted data, what it looks like, what's the content there. And then we use Kibana. For those of you who know it, it's an analytics tool that allows us pretty much to do trend analysis, aggregate together data, and pretty much pull all the nice charts that you're going to see soon enough. So In terms of data sources, this is what we try to monitor. So we got user data, anonymized user data. Pretty much, we can see all the connections that come from our users in an anonymized way. We pool all the connections to URLs that are DeepWeb related, so either .onion or Tor gateways, like tor2web.org or things like that, I2P, and so on. We monitor pastebin sites, like pastebin, Slacksy, and so on and so forth, to look for new URLs. We have access to a 1% Twitter feed, which will eventually become a full Twitter data hose, just to see exactly if somebody publishes DeepWeb-related URLs in tweets. We monitor Reddit and some subreddits like our Onions, our Tor, our Darknet marketplaces, I think, and some other. There are some actual websites that pretty much host pages full of URL DeepWeb links, like onionlinks.com or things like that. We just scrape them periodically to find some new upcoming links. Tor gateways, so as I mentioned, there are gateways like tor2web.org or onion.cab, onion.ct, and so on, which allows you to access hidden services on Tor pretty much without having Tor installed. Now, you're not guaranteed anonymity, but you can still access the content. So malware, for example, some malware can use it since they don't really care about being anonymous on the client side in that sense. And the good thing about the website is that they keep statistics on what are the most accessed hidden services per day. So we can just access those statistics, they're public, and we pretty much get a list of the most popular hidden service any given day. I2P host files, so this is something, if you remember, emule, the old server.met file, this is something similar. It's pretty much a text file that gives you a plain text list of I2P domains in a readable format with their correspondent hash key, which is the actual domain. So there are text files. Again, you can download them and sort of use them to update your I2P instance, but we use them again to find newly registered sites, for example. And then, of course, when we scout a page and we find new links, we feed them back to the system, actually as a data source on its own. In order to access the whole ensemble of hidden services, we actually have a machine that acts as a universal proxy, as I call it. So it pretty much runs a squid, a transparent proxy, that depending on the request, pretty much forwards it. If it's a .onion, it forwards it to, we have 64 Tor instances running Polypo. If it's an I2P, we have an I2P instance. If it's FreeNET, there's a FreeNET instance running there, and it can resolve DNS for pretty much every DNS provider, so either normal domain or all Namecoin and Emercoin DNS or rogue TLD. So you pretty much just connect to one port, and you can resolve and access all the data in there, which makes it pretty convenient, either if you are a researcher and you just use that as your tunnel to inspect the content, or for all the automated data retrieval. I mean, it makes things way, way easier. In terms of page scouting, so this is the kind of information we retrieve. So we have a headless browser that goes, connects to the URL and tries to fetch all this information. So it fetches the full har log, so all the HTTP connections, not just the redirection chain, like everything that comes out of a browser page. It renders the full page, so even if there are dynamic pages with JavaScript and so on, we get the final rendering, and then we scrape the text, get the screenshot, title, text, all the metadata, such as meta tags, keywords, and so on. We store, if needed, the raw HTML, and we parse the page for links, emails, and Bitcoin wallets. To do this, we actually use this nice piece of software which is called Scraping at Splash, which is basically a Qt WebKit instance. So the engine is pretty much the same HTML engine that you find in Google Chrome, packaged in a nice Docker container. So you just need to download it and run it pretty much, and it saves a lot of setup hassles, basically. You can script it with Lua. It actually supports no-script filters if you need to. And again, he has that very nice thing that gets us full HTTP traces. So to actually access that, we patched a couple of Python's middleware libraries, if you are the Scrapy middleware library. So if you use Scrapy before, you can have middlewares that pretty much reworks your URL and reaches them before throwing the request. So we patched them so that we could use Splash together with some shared queue so that we could launch multi-processes, basically, and achieve better performances. And then, as I mentioned, extract links, emails, Bitcoin wallets, and so on. In terms of enrichment, this is what we do. So for all the links that we pull out of the pages, we get our web reputation system and see if the links might be malicious, might be safe, and if they are malicious, why? Are they malicious because they have a proxy vector, disease vector? Are they malicious just because, might be the Tor web page and then it's proxy avoidance and might be considered malicious, and so on. We do translation. So we first detect the language using a Python library and Google Translate. And if it's a non-English page, we try to pull the English text back and translate it. With the English text, what we do, we actually try to pull what we call a significant word cloud, which means that we compute a word cloud after having done some clustering of the words based on their meaning. And the clustering basically works this way. So we get the page text. We scrap them from HTML, clean it up, strip spaces, and so on. We do a tokenization of the text. So from the text, we get to a list of word and frequency pairs. So this word has appeared 5 times in the text. This word has appeared 10 times, and so on. We filter it to keep only substantives. So take away verbs, adjectives, adverbs, just substantives in our list. Of the substantives, we do a distance matrix, a semantic distance matrix, which means that we compute how far are words from one another. So take, for example, the word baseball and basketball. These 2 words would actually be very close into meaning because they are both sports. If I take, say, car and cat, these words are actually fairly far because one it's an animal, the other it's a mechanical thing, basically. So there is a library in Python called WordNet, which is used to do such thing. They already have compiled the whole list, graph of meanings of all the words in English. So you can basically use it to compute, again, distances between words and their meanings according to their categorization. Once we have the distance, we use it to do a hierarchical clustering. So we group together words that are similar, like DB, list, storage, and so on. And we label these clusters taking the first word of the group in alphabetical order. The cluster gets an overall frequency, which is the sum of all the frequencies in the word. And then we use that information to draw a word cloud. The purpose of all this mess, it's pretty much to be able, if you're an analyst and you end up, for example, in a non-English page, such as this, to get at a glance, the general topic of the page. So here we got a Russian Silk Road something something. I don't speak Russian, so for all it matters, it could talk about flowers and cooking. But then I can spot from the word cloud immediately that is, forum, about trading resources and so on, and I can, see immediately if it's something that interests me or not. For example, if I'm doing an investigation. In terms of storage, we rely on Elasticsearch, which is a full-text search engine. It works similarly to Solr, for those of you who know it. Relies on inverted indices, basically, to index your data. So you feed him a text document, converts it into tokens, and then can tell you that that word appeared on this document, and this document. So it allows us basically to do free text search right away. Just type a couple of words, and you can get your results. It also allows us to do some structured queries, and we'll see them in a minute. Like for URL, I can actually ask for all the URLs that contain a certain query parameter named XU, for example. It allows us to do analytics. So we can do analytics on both the URLs. So see, for example, how popular a certain query parameter is, or when we first saw appearing a combination of hostname and path. First day we saw it appearing. We can do analytics on Scout data. You'll see like what languages are most popular and so on. And again, we can use like either Kibana or our portal to do data exploration there. So this is the collected data. We had the system running for 2 years now, almost. We collected overall a 4.5 million events, meaning that by event, I mean we spotted a URL. It doesn't necessarily mean it's a new one, but we spotted in one of the sources. We collected what was 600,000 individual URLs for a total that should be like 20,000 domains, give or take. Keeping in mind that DeepWeb data is very volatile. Like you're looking at the data at a certain moment, then the next day they decide that there's Operation Anonymous, and all of a sudden 2,000 domains, poof, disappeared. So this is the historical number of domains. Active domains at the moment, we are probably around 9,000, 10,000, I'd say, like last couple of weeks. So without further ado, I prepared a couple of videos to show you exactly what it looks like. So this one is, again, the main page and the URL analytics. We got our general statistics that tells us, if the sources are doing well. And here we have all our URLs pretty much grouped by hostname, path, and query string. We could actually search according to multiple, again, a green URL means that we scouted is successful, yellow means that we had an error while we tried to connect to port 80, and red means that it's malicious. We could actually search by parameters, for example, the DeepWeb type of a URL. So in this case, we want to filter and just get the I2P domains. We can filter and just find malicious domains, which means domains that contain pages that had malicious links. Here we found, for example, a scan4u.I2P, which is a counter AV service. So it basically allows you to test your malware against all the AV engines and find out if it's detected or not. So as you see, we can have the path breakdown, query string breakdown, and then you got all your information, HTTP headers, page title. You got your word cloud like there, which gives you immediately the idea of what it does. A screenshot there. Here are the word clusters. Again, as you see, we group together things like list, database, blacklist, and so on, spyware and software, and so forth, to sort of reduce the amount of words that we get. Under there, as soon as it gets there, under there we got links. In green, you have the safe links, untested in yellow, and malicious links in Y in red. And then all the other things like meta tags, keywords, and so on. So this was for what concerned URLs. Then for the scouting page, we have another tab, which pretty much allows you to search into the information we scouted. So we crawled, all the pages that we crawled. So here's the list of the latest scouted pages. Now we wanted to make a quick experiment and see exactly if we type hack in the box, what would appear. So we just did a quick free text search. And we got, well, one website that seemed to have the keyword over there, which is an open directory, actually. So if I open it up, I can see that, well, first of all, we got a redirection chain that we can log over here. So a 301 followed by a 200, which is still always useful because you never know what you can find from there. In this case, it's an open directory, so the word cloud is pretty much just directory, XO, 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 and anti somehow. So it doesn't really tell us much, but you can see from the screenshot that it's pretty much just a directory listing. If we go down, we can see that one of the directory folder right here is our HITB. So this seemed to be just a collection of magazines from somewhere. But the interesting thing here is that on the topic of open directories, I can actually use the system to find, for example, all the open directories, certain kind of open directories in the DeepWeb. So there's a format of open directories, which is the one generated by wget, that it's known because it generates a URL in the format that contains a query parameter named C, and the second, which is the sorting criteria, and another query parameter named O, which is the sorting ordering. Now, I can just look for those two query parameters and pretty much find all the open directories that we scouted in the DeepWeb right there, which is a fairly interesting thing in there because you can then go and look exactly if it's some interesting content, if it's, I don't know, some dump of images or other data that you can find interesting. So we got other projects, for example, that are dedicated to that, and I can just feed these URLs to the other projects. And there again, your directory listing, word cloud in this case doesn't really help much because it's just a collection of our files. But still, this is the kind of queries that we can do over there. So moving on, let's see some examples exactly of things that we managed to find with our systems, basically, and some nice examples of stuff that you can find amongst all the websites. So first of all, guns. I mean, who doesn't like guns anyway? People love guns apparently. And here, if you live in the UK, apparently, or you could. I don't know if the site could still be online, but for like 1.4 Bitcoin, you can buy a full unregistered gun and do gun stuff like, I don't know, I never use guns anyway. So drugs, I mean, I didn't even think I needed to mention it, but of course, I mean, this is what people know the DeepWeb for. You can buy every sort of drugs, coke, heroin, mushrooms, LSD, whatever, it's your deal. Just go up there and face probably incarceration, but still. This is pretty much 80% of all the trades, like the things traded in the DeepWeb, and most marketplaces just rely on that. It's a big driver. More interesting stuff, passports and fake IDs. So there's more than one website that actually offers counterfeit passports, counterfeit fake IDs, US citizenships, all sorts of stuff. Now this, given In homage as the organizer, I just wanted to show them that I could actually get a Malaysian passport for 450 euros. With 650, I could actually get a driver's license, and pretty much sneak into the country in case I needed to. You can actually get even copies and everything. And well, here, of course, I mean, the most expensive one seems to be the USA passport for obvious reasons. Moving on, counterfeit money. Again, here we showed an example with Chinese notes, but you can pretty much find any banknote of well, at least the most famous one. Chinese notes, European, US dollars, every sort of stuff, it's right there for the picking. Or at least that's what they claim. The one thing about these marketplaces is that they claim they will sell you stuff, but you're still buying on Bitcoins, which is untraceable, and it can't really taken back if you're scammed. And they're shipping from nowhere, you don't know where they are. So they say they will sell you counterfeit money, but then we are not really allowed to go and try it because that would be financing of illicit, of criminal activities. So this is what they claim. Credit cards, stolen and cloned credit cards. You can see that for $90 you can actually get a nice 2,000 Visa card with a 500 daily limit. Of course, the higher the balance, the higher the price over here. Still kind of convenient, provided that they work. PayPal and eBay stolen account. Oh, where was it? Sorry. Here they're selling bundles. So with $100, you can actually get 100 PayPal accounts with an average of 20% working. And they even have a kind of a cashback guarantee. Like they will replace them if more than 20% don't work. So in the end, you pay $100 for probably 80 PayPal accounts working. Again, if you have to do social engineering and stuff like that, this is the kind of things you're looking for. Doxing. So there are some pages that actually provide public information of high-profile figures. In this case, we got Bill and Hillary Clinton, Sarah Palin, and all the addresses. Incidentally, we left these addresses uncovered because 1600 Pennsylvania Avenue is actually the White House, so there's really not much. It's not such a big news that Hillary Clinton lived in the White House in the past. Joe Biden and so on. That's actually the picture of the address above. You can actually find it on Google Map if you want. Assassins. So there are 2-3 pages that claim they will offer you assassination services if you pay, and get some of the guys they will get rid for you of that little annoyance in your life. That's actually how they define it. So here as well, 5,000 euros you can kill a person. That makes it so easy. Then again, keep in mind, I have no way of saying if this is legit or not. Most likely, it's probably a scam or something. But I have no way of saying. But think about this. If I have, the chance of setting a website that isn't traceable, for most part, it's hidden and I can stay anonymous and I can receive payments with the currency that is untraceable as well and pretty much cannot taken back. And I had the chance of sort of scam the kind of people who cannot really go to the police to say that they got scammed while trying to hire an assassin. Well, that's something that I would do. Like, it looks like a good business plan if you need to scam people. I mean, there's not like anybody's going to go to the police and cry that they spent 5,000 euros for an assassin that wasn't such. On the topic of scams, this is another interesting thing. This was on a website that it brought the thing on a whole new level. This is like a Kickstarter campaign for evil. So what the guy would ask you, like they got projects, like assassination project, like Obama, Hugh Grant, the business executive, so Justin Bieber, of course. The guys are trying to crowdfund and collect money to kill these guys. So, status still alive, we're trying to kill him. If you want, just send us Bitcoin. And when we reach a certain amount, I think it was $2 million for Obama, they will certainly hire an assassin and, make the deeds in your stead. Sure. I mean, again, think about it. If you really had to put a website and know that you'll be untraceable and you can get money that, again, cannot be taken back, wouldn't you do that? I mean, come on. This is just, again, I haven't tried to crowdfund them myself, but as a proof, Justin Bieber is still there doing concerts, so didn't really work so far. So let's move to the more analytics part. Here I'm just going to show you some of the data we actually pulled out our nice Kibana interface. Protocol breakdown. So this is the breakdown of all the schemes we found in the public URL we got sourced. So these are not like active port scanning and stuff. We collected URLs. What were the schemes of these URLs? So I took away, of course, HTTP and HTTPS, that being like 90% of what we found, clearly being most websites. If we take them off, we can see that we still have a fair amount of IRC sites or IRC URLs, like 172 on different ports. We got IRCS, like 17 more or less, and XMPP. These three are very interesting because these could very well be used for infrastructure for CNCs or rendezvous points for malicious actors and so on. XMPP is the Jabber protocol, so it's instant messaging. If we do a more active scan, this is with the port scan we actually did, we found in the, probably 2 days ago, doing a scan of all the domains we actually still found 49 IRC servers, 31 IRCS, and 855 SSH port open in all the domains, which is kind of interesting. And amongst the sites, this was one of the IRC servers that Cyber Guerrilla, AnonX or something seems to be hosted, Anarchist Control and so on. And he had a nice channel, Free Anons, which seems to be a channel to give support for arrested Anonymous or Solidarity and so on. In terms of languages, of course, per domain, English seems to be the one who have the highest number of domains, followed by Russian. If I take them away of the equation, what's left is like French, German, some Catalan, Portuguese. These are the main languages that you can find, included Chinese, for example, in the smallest part. This is an example of a Chinese site. Google Translate told me that these are some trading rules for a Chinese marketplace. I reckon that you might give it a better meaning than I do. In terms of suspicious links, again, we could actually find in the pages with more links deemed suspicious in the terms of malware and so on. So this was one of the pages we found. It's a marketplace where people are basically selling predator pane and malware and keylogger and things like that on a DeepWeb forum. Email identification. So another thing that we can do while we scrub the emails is that we can find out what are the most popular emails, on which sites, and so on. On the number of sites, and what are the related emails. So in here, the most popular are not really that interesting because, some are just gibberish. Like we use a regular expression. So you see, we got the *** at onionmail.in, which doesn't really mean much. ZZZ at mail.i2p, that's one of the lead developers of I2p, so again, doesn't really mean. But if you look in the lowest half, we got things like toxic poison at yahoo.com that seems fairly interesting. We got some guy who's called Bank of America at mail2tor, which was kind of caught our attention there. And if we click on that and we see the associate email addresses, we can see that it generally appears in pages together with other addresses such as Nullcode, Cherry9, Psycho Tokyo, and so on. Now, we went on our portal and searched for pages containing this email, and what we found, for example, was this forum post on the Exilio forum, where, for those who doesn't speak Portuguese like me, seems to talk about selling credit cards and stolen credit cards by this Nullcode guy, and we see down in the forum that there's basically this Bank of America guy answering, so we can see this kind of interaction, raw social network analysis still. In terms of Bitcoin identification, we ran again a regex to find these Bitcoin wallets, and we find more or less 1,200 Bitcoin wallets there. And we consider that not to be the whole, the total amount, because some sites, like you'll see in a few minutes, actually employ some obfuscation techniques for their Bitcoin wallets. Like, for example, there are some pages that would take the wallet, and instead of showing the whole string, they will split it into blocks of 2-3 characters in the HTML code, and then use a CSS just to rebuild the whole thing. So you will see the full wallet, but if I run a regex to find, strings between 23 and 26 characters starting with not 1 or 3 and so on, you will not find those. But this, anyway, it's a number of proper wallet candidates. And on the topic of Bitcoins, since, this is actually the king currency on the deep web, these are the kind of services that we will find. We got Tumblers, for example, which is pretty much money laundering. So you send them 10 Bitcoins, they retain a fee, and they send you back 10 Bitcoins minus the fee, which happens to be clear. This is because Bitcoins and cryptocurrencies in general have this feature that they're untraceable as long as there's no way of linking your name to your Bitcoin wallet. So if you don't leave out any information that ties your name or your user to a Bitcoin wallet, then you're safe. But from your Bitcoin wallet, which is pretty much a hash string, the full transaction ledger is public. So if I have your Bitcoin wallet, I can pretty much go all the way back and see all the transactions that led to your wallet. And going forth, I can follow up all that you're doing. The problem that law enforcement are having is that they cannot generally tie a Bitcoin wallet to a person. So to solve the first issue, there are tumblers like this that pretty much sends you some money that is tumbled around so that following up the transaction chain is very difficult. On the other side of the coin, and pardon me the pun here, there are things like Bitcoin Multiplexer, which are sites that claim that you send them 1 Bitcoin and they will send you back 100, which is probably, again, the way how money laundering services find the money to send you back. They just get random money from people with the promise of sending back money. Of course, it might very well be a scam as well, because again, you send them 1 Bitcoin, if it's a scam, you're not going to get it back anyway. But in this particular case, the site tries to build up a reputation by actually showing you successful transactions and all our happy customers that we got there. So I now leave the word to Marco, which is going to talk more into details about malware and how malware exploits the deep web to his deeds.
Okay, cool. So thanks, Vink. So we still have 20 minutes to go here. I think it's more than enough, so you have time for questions later on. So to move on, I have to say that malware nowadays is heavily network dependent. Okay, so 20 years ago, malware was just some floppy disk. You get the floppy in, you are infected, done. Now malware to operate usually need the network. You need it at the infection time, propagation time, and the operational time. For example, propagational time, if you look at APT, about persistent threats, what's happened usually is that when you get infected, what the attacker wants, he wants to do lateral movement inside the company. So he wants basically from one computer to move to another computer. So there might be second malware or first stage malware being used to do better attack over the network. The same is with the fact that the malware wants to be persistent. So to be persistent, you want to be in the network as much as possible. So usually the malware communicates, as you all know, with external command and control server to leak, for example, to fetch, for example, new code, up-to-date code, or to leak to a drop zone, for example, the data that have been harvested on the machine. So the goal for a malware author or cybercriminal in general is to make the botnet as resilient as possible to, for example, law enforcement operations such as sinkholing or takedown. So their goal is, for example, to hide the command and control server, or to conceal the payment page, for example, in a ransomware, or to make, in general, money transfer untraceable. So there was already a talk, a kind of initial talk made by Brown in DEF CON 18, 5 years ago, about the possibility to use Tor as a system for setting up a command and control server. At the time, it was just a kind of proof of concept. Nowadays, here I'm going to show you actually some real case, malware, but nowadays use Tor and the deep web in general for to achieve this goal. So one of the first malware we saw is Skynet. This has been actually discovered a couple of years ago by some guys at GData and also Claudio, which was working for Rapid7 at the time. So basically, this is a malware with denial service, Bitcoin mining, and banking capabilities. So it comes with a Bitcoin mining tool called CG Miner, which actually uses the infected machine to mine some Bitcoins. And it also comes with a Zeus botnet, the Zeus bot, which basically harvests online banking credential for an infected machine. And the credential are then uploaded to a drop zone, which is running on this gate.php landing page. And it does it using a Tor client for Windows. So basically, the malware comes with a Tor client embedded in the binary. So what we can do using our portal, which is actually a screenshot of the portal you saw before in the demo, is, for example, to search for a specific path. For example, it could be gate.php. And we can see that there are 367 victims that reach out to this machine, to this path. In particular, at the time, there were 2 different domains being used as command and control server by the attacker. What we can do, we can plot over time, for example, over the last 6 months, which domain have been used as command and control. And we can see that at the beginning, On the green side, there was a single domain being used called SVC, whatever, I mean the first one in the legend. And then it fade out and it get in another domain, which is the second one, and then some additional domain. So it seems that the campaign is ongoing, and there are actually more and more command and control servers that are introduced into the malware campaign. A second malware that it's kind of interesting to mention is the dire bank intrusion. This is the first malware which makes use of I2P to host command and control server, which is, so as you saw before, something different than Tor. So this is actually a BHO that man in the middle online banking pages at browser level, and it does in a way that basically when the user connect to online banking and log in, what the malware does, it connect back in a kind of reverse shell approach to the attacker, and in that way the attacker can log into the machine, into the online banking application of a victim. And so to operate, the malware used different domains, different command control domain. So in particular, it used DGA, which is domain generation algorithm, to generate a kind of runtime command and control server hosted on the ClearNet. And then it does it, and it also does it on I2P, both on port 80 and port 443. So last year, some guys from Dell Secure Work discovered the malware and attribute the first domain here and HG to this malware. So what we did, we discovered 2 additional domains being used by in the same campaign, and these are actually heavily used nowadays. So for example, this is a plot of October 9th, a couple of days ago. So we can see that every day there are between 40 and 80 requests per day, and pretty much one every hour, I mean more than one every hour of requests going out to the command and control server. Another banking Trojan, which uses the DeepWeb to hide the command and control server, is Votrock. This is a Trojan that spread using phishing emails, which is a common way now to spread malware, because actually we saw that spam decreased a lot in the last couple of years. So it seems that the techniques used for spam filtering works pretty well nowadays compared to 20 years ago. So malware authors start using spear phishing to do to spread malware. So what the malware does, it basically uses some command and control server that are hosted on the normal clear web, but the IPs, they are steganographically hidden into the icon file, the standard icon file used by a website, which is favicon.eco. So this is the first layer of first technique used by the author to hide the IPs. In addition, this favicon.eco is hosted on a website which run on the Tor networks. So basically, the malware author have the Tor network. We provide a grant of anonymity. Then they use this favicon.eco. And then inside, they basically steganographically hide the IP address of a command and control server. And the icon itself is basically just a normal icon. So if you connect basically to one of the servers and you don't know in which way is stenographically hidden, you cannot find out. So what we did, we did an analysis on the web server which is running was hosting this image, and we found out that the web server is a particular version of OpenResty, the 1.7.2.1, which is a good fingerprint that we can use on our side to detect command and control server. And in addition to that, when you basically query a web server for this favicon.eco, instead of having like a 200 return value, which is a normal value for OK, the file is here, you get a 403, which means forbidden. So basically using a combination of these 3 heuristics together, so the fact that there is this specific web server, which is an information that we scout in our system because it's in the HTTP header. So given that information to the existing favicon.eco and the return code, we basically get every day a fresh list of new command and control server used by the malware authors. And here we have the plot over time from beginning of February when we first the infection to a couple of days ago. And we can see that also this malware is getting more and more prevalent into the deep web because more and more traffic is shown on our end, more infection. And a particular type of malware seems to love the deep web. Okay, not only because it's a perfect place to hide the command and control server, but because the deep web provides a hidden and robust framework for cash out operation and for illicit money transfer. So for those of you that are not maybe aware of how it works, basically the ransomware is a malware that whenever infected your computer, basically it locks you out from the computer. Either it tell you, okay, dude, you cannot use your computer anymore because you visit some pornographic website, or what it might do, it might encrypt some of the important file you have on your disk, like some Word document, and might ask you for a ransom, like a fee to pay to get your computer or your file back. And usually this is done in such a way that you get redirected to a page where you have to pay. Okay, you have to pay $100 or 1,000, depending from the type of file and the malware you got. And the time you pay, you get your computer back. So one of the goals of the author is to conceal this payment, okay, to make it also untraceable. And one of these malware is a variant of cryptolocker, so one of those ransomware that encrypt the file on your disk. And this malware is called TorrentLocker. So TorrentLocker, it conceals the payment page in Tor, okay? And so that's the payment page you get redirected when you are getting infection. So basically just say, okay, you want to get your file back, you have to pay, how much is it? 1,200 Australian dollars within 2 hours. And if you pay that, you get a file. And of course, if you don't pay, basically the ransom get higher. So maybe from 1,200 it goes to, I don't know, 500, okay? Until you are forced to pay if you want your file back. And some interesting point is this one, that the payment page is hidden in Tor. And the second thing is that the payment is done using Bitcoin, which makes it more difficult for a law enforcement agency to trace back to who is behind, especially if they use one of the techniques like Vincenzo showed you before when he was talking about Bitcoin obfuscation. And no, this one I was mentioning you. The Bitcoin, I don't remember the name. This one. Bitcoin Tumblers. So if the bad guys actually they use this system behind, basically they interrupt the chain, and there is no way to trace back to the actors. And another interesting thing here is that the address here, you see on the bottom here you have address, a Bitcoin address. So this one is get rendered as a Bitcoin address, so a chunk of something like 30 alphanumeric character. Upper and lowercase, but actually in the source code of HTML is actually split in a chunk of 2 and 3 bytes separated by a space. And then there is a JavaScript that combines this and show it as a normal Bitcoin address on the screen. This is done in such a way that it's very difficult to automatically identify those pages because a crawler cannot get the Bitcoin address because the Bitcoin address is shuffled in the raw text or in the raw HTML text. So what happens is that what the malware does when you get infected, it generates some univocal IDs, what is called here in user code and user pass. So these IDs, they basically are a kind of access token that grant the access to the payment page only from your machine. So basically, if you don't have this token, you cannot get to the page. So it's a further way used by the author to protect his infrastructures. So what we did, we basically built a regex out of this query string. And what we can do, we can apply this regex to our system. Our system basically automatically identify those pages. And in particular, this univocal token, they also influence the language in which is generated the payment page, which means that the malware keep track wherever the machine which has been infected is Chinese, as could be here, and in that case you have to pay in kind of Taiwanese currencies or in other language. So by querying our infrastructure, we can query, for example, for the language, the detection language we have on the payment page. And we can tell you, look, most of the infected users, they are English-speaking native, okay? And because it's the green slice here, followed by Turkish, French, Chinese, and Italian. And as well as the different command and control server that the bad guy use. So for example, you can see that the command and control server, which is this one in red, actually is used by victims in UK or US and Turkish, okay? And so one final malware I want to show you is Name.Space. This is very rich in malware and very effective in the sense that it's not only bank intrusion, but actually does everything. So it steals any type of confidential information you might have on your computer. So it steals keystroke, both at the browser level and operational level, password, any kind of private document, and it also has the ability to record audio and video using your webcam, which makes very suitable for espionage program. And so the idea here is that suppose we don't know a priori this malware, okay? So we don't know the format of a query string, we don't know the way to communicate with the command and control server. So the question is, how could we possibly detect this malware looking at the traffic? So the idea here is, our idea was to use as detection feature the popularity in the number of values associated to query string parameter. What does it mean? It means that I can look in a short time period, it could be like 1 hour or 1 day, if there is like a boost in the number of value associated to a new parameter. Because if you look, for example, at this screenshot, you can easily see that in the last day, there is this new parameter called XU, which is a bunch of different values associated to it. Okay, and you say, okay, cool, this is very weird. And this is normally a behavior of malware, especially if malware communicates using GET and not a POST. Basically, the value used to communicate to the command control server are encoded into the URL itself. In particular, this type of malware used 2 different parameters to communicate to the command control. One is called XU and the other called XD. So the XU in particular experienced a huge surge in popularity. It had more than 700 values over the last couple of weeks, which makes very appealing and very interesting and very easy to be spot. And by looking at the payload, you can see that the payload is an URL encoded binary block, which turn out to represent the data that have been leaked from the machine. So basically, the malware infected the machine and the recording of a keystroke you're typing. Every time he has to send out the information, basically what it does, he encodes this information in a binary as a URL encoded binary payload, and he sends it to the command control server, which is a PHP script. And so that's one interesting thing. The other interesting point is that when you get infected, the malware report back to the command and control server the information of the victim. Okay, so the operating system, the version, the language, where it's located, and anything else. And it does it using another parameter called XD. And what it does, he encode using JSON, not encoding, but basically he uses JSON as a way to communicate with the command and control server. So what we can do, we can plot on the x-axis the timestamp, and the x on the y, like the domains. And we can see that here, for example, we have 2 domains, especially that one on the top, which is used as command and control server. And we can see that in blue, so I'm actually in this line here, we can see the new infection per day. So the number of new victims that have been infected per day by this malware, which use Tor, of course, as infrastructure to operate. And in green, like the amount of leaked information in bytes. So basically, to conclude here, we show you how we build like a system that we used to collect data in the DeepWeb, not only in Tor, but also in FreeNET, I2P, in a network that use rogue TLDs, so non-standard TLDs domain, and that allow us to do semi-automated analysis. So basically, we are currently using this system to identify new cybercriminal activities, such as the trading of illegal goods, the new marketplace, as soon as they arise in the deep web, what has been traded there, the different scam because we believe there are a lot of scams going on in the deep web, and this is something we want to work on in the future. And also, the new malware which spread and they use the deep web in different forms, like for example ransomware, which use for conceal the payment page, or Name.Space, which use for the command and control infrastructure. And so we basically conclude our question, and we have 5 more minutes here if you have some question for us. Otherwise, we'll be around the whole day, or you can send us an email or a tweet. So thanks for listening. I hope you enjoy the talk.